Good day everyone and welcome to the Festival Tech Calendar of 2025. Whole month long, every day a new video so you can learn something new. So I think this time is well spent. And today I have the honor to give my presentation optimizing Power BI and enhance performance through data modeling. And I explain today how you can create a well-designed data model, how you can do that on the best way, but also the why it's important and what are the impact on your data model if you change, for example, a data type. So I show you that with examples so you know how you can create a well-designed data model. But first, let me introduce myself. I'm Peter van der Bos, I'm living in the Netherlands. And I work more than 10 years in the fascinating world of business intelligence. And from 2016, I work only with Power BI. And I focused only on the data modeling and how you can perform and optimize the data model on the best way, also with your DAX. So that's my main focus, but I also give trainings and I make videos and sometimes I blog on LinkedIn or YouTube. So if you want to follow me, it's always possible. And I think we have enough about me. And let's start with how you can create a well-designed data model. Let's dive in the presentation. Before we dive in, here are my contact details. You can always download the slides from my GitHub. And feel free to follow me on YouTube and LinkedIn if you want to learn more about Power BI. So the first thing you should ask yourself is, why is the data model important? It's the foundation of everything you do in Power BI. So a well-designed data model improves your performance and speed up your queries. Many customers ask me, my report is slow, can you fix it? And in 80% of the cases, the root case is a poor data model. So if you have a well-designed data model, your report is also not slow. I often see long and complex DAX queries, and they are very complex, and the writers of that are very proud. It's work, the values are correct, and I understand that. But in the most cases, I think, okay, your data model is not well designed. If you have a well-designed data model, you can write very simpler DAX, and simpler DAX lead to faster reports. And it also reduces your data redundancy and minimize your errors. And the last thing why data model is important is Power BI is an in-memory tool. So all the data is stored in your RAM memory, and RAM is very expensive. If you have a license, like a Pro license, you can store 1 GB in your memory. So if you have a lot of data what is repeating, you store a lot of data in your data model, and you can ask yourself, is that necessary? So the last thing is the compression of your data. The compression of your data is very important. How better the data is compressed, how more data you can store in your data model. And the engine behind Power BI is the Vertipack engine. And the Vertipack engine compresses the data on the best way how it is possible. So it's very important to know how the Vertipack engine is work and what's possible to store your data on the right way. So let me explain how the Vertipack engine is work. And I explain it with these two columns. We have a column with unit cost and we have a column with store name. So the first compression Vertipack is used is the dictionary encoding. And the dictionary encoding is, we have the store name column, and Vertipack replaced the unique text values with a numeric key. So we create a mapping table with all the unique values in the store name. You have a unique ID. That saves a lot of memory. Text is costs more memory than a numeric value. So he stored all the values in a dictionary. So if it is necessary to find and store name, he used the dictionary to translate the ID to the store name. And this is very effective with a low currency column. So how more distincts you have in a column, how worse the compression is on the column. But that's the first compression on your data. The second compression on your data is the run length encode. We use the column what we have created with the dictionary encoding. And the column is a store name ID. The first thing the Vertipack is creating is a column where all the IDs is grouped with each other. So we see all the IDs are grouped with the other IDs. And why is Vertipack grouping the IDs? So we can store it in another table. And the table he creates in this case is 3 columns and 3 rows. And the ID 1 starts by row 0 and it is repeating 4 times. And ID 2 is starting with row 4 and it is also repeating 4 times. And the last ID, ID 3, is starting with row 7 and it is repeating 2 times. So we have in this example a small table with not a lot of rows. But if you have a column with 1 million rows or more and you can store all that rows in a small table with 3 rows and 3 columns, you compress the data on a very great manner. And that's very effective. So that's the reason Vertipack used this technique to compress your data on the best way. Then the last compression technique is the value encoding or bit packing. And it compress the numeric values. So Vertipack finds the minimum value in the column. In this column is the unit cost. It stores each value as a difference from the minimum. So in this case we have the minimum is 10 and you subtract that from every value. So we have in the column 11 and we store an 1. So in that case we have fewer bits, and fewer bits is less space in your data model. So that's the last compression technique Vertipack is used, and use a lot of more, but that's also the secret sauce of Microsoft. So we don't know everything, but that's what's known about the Vertipack engine. So what's happening if I load a file into Power BI? In this case I have a file, it is an Excel file and it's one big table, it's 117 MB and I load it into Power BI. And the Vertipack engine is working on the data, and if I measure the size in the memory, then I have 111 MB. So the compression worked very well, but we can do better, and that is to split the one big table to separate tables. And if we separate on the right way, then we have 20 MB in our memory. So we load a file with 117 MB and at the end we have 19 MB in our memory. A great compression on your data is a 10:1. And what that means is I have 10 GB in our data warehouse. I load it in my data model and I create a well-designed data model. Then I have 1 GB in our RAM memory. So that's the compression, and you must search to the best way to compress your data. But if you have a ratio from 10 to 1, you have a great compression on your data model. Sometimes it's a little bit better, sometimes a little bit worse, but focus to the ratio 10 to 1. So I'd say we can split the one big table to different tables. And what I mean with that is, in this example we have the big table and we see all the store information on every row. So not only the store name, but also the store description, the status, the open date, and a lot of more information. And that's repeating every row. And you can ask yourself, is it helpful to repeat all the store data on every row? And I think not really. It's ineffective and it's redundant all the data. So how we can fix this? I've moved all the store information to a separate table, and in that table I have only the unique values stored. So I removed all the duplicate values. So I create a dimension table. But in that case I have a fact table with no store information, and I have a dimension table. And later I explain the fact table, but the dimension table with all the store information, that's the unique values for the stores, they are separated. So I need a relationship between the tables so I can filter from the dimension to the fact table. And we call that a relationship. And we need in every table a column with the keys, the store keys. So I moved all the store information, but there is one column with the store keys, and I have leave that in the fact table. So in this example we see the fact table, we see the store key, and in this case it's 199, and we have the dimension table. And we see we have 3 stores in the dimension table. That are the unique values. So if I have 1 million rows and I'm repeating everything, it's not very handy. So a dimension table works a lot better, also for the compression. So we see also in the dimension table a column with store key. And I now filtered only the Contoso North America online store. And we see in the store key only the 199 key. So this is an optimized data model. And we see in the fact table only values where we can make relationships, but also where we can calculate on. So that is very important. So a fact table contains facts, so representing an event with the dimension, like a sale with a product, customer, and a date when we sold the product. And all the information in the fact table, in this case the sales table, we want to measure. So we calculate the values. Then the dimension table. In the dimension table we store information what is not changing or not changing very often. So in this case was, for the example, the store information, but it's also possible to have the customer, the employee, or the product. And if we have the fact table and the dimension, we must create a model, a schema. So the best schema you can use is a star schema. And in this case, we have the sales table, that's the fact table in the middle of our model, and around it we see all the dimensions. And someone saw that and say that's like a star, so it's a star schema. So that's the engine from Power BI is optimized to to use a star schema. So he can calculate very fast the values if you have a star schema. But it works very nice also for the business users if they want to create a model or a report. They want to filter with the products or the different dimensions on the sales table. And if you must make a choice about a column, a rule of thumb is think about a bar chart. Everything on the axis are the dimensions, and everything in the bars that are the facts. So that's very easy to, if you must make the choice, is this a dimension or is this a fact? Think about the bar chart. So then we have a little bit of variation of the star schema. That's the snowflake schema. And in a snowflake model, dimensions table links to other dimension tables. So in this case, we have a product subcategory, and a product category, and they are linked to each other. And we linked always the lowest level to the fact table, in this case, the product. And a snowflake is not wrong, but a star schema is preferred for a well-designed data model. But sometimes I have a table with too many columns, and I try always have in a table 15 columns, not more. And sometimes it's 17, but I try always to have 15 columns. And if I have more columns, then I separate the dimension in different dimensions, so I create a snowflake model. So that is one of the reasons. That's one of the reasons I use a snowflake model. So a little bit repeating, but what does an optimized data model consist of? A fact table that contains the values that you can calculate, like revenue, purchase dates, sold products. And a dimension table contains the values you want to filter by: year, month, manufacturer, or customer. So then we have created the facts and the dimension. But we need a relationship between them. And we have a primary key that consists of, that's a unique value that appears only once in a dimension table. So we have one unique key for every store in our table. It is not possible to have one store with many keys. If that's happening in your dimension table, you must go back to the drawing board. Then is your dimension table not built on the right way. Then we have also the foreign key. The foreign key, you find that in the fact table, and that indicates how often, for example, a product has been sold. So a foreign key can appear multiple times in the fact table. So we have now the relationships and the keys, but we must also filter the relationships, and the filtering is working on this way. We have different relationships. The strongest relationship is a one-to-many. So we have a unique value in the dimension, and we have many values in our fact table. So that's a strong relationship, and that's always the first choice. Sometimes you have a one-to-one, so that means you have one unique value in the table, and you have also a unique value in the other table. But in the most cases, that's it. If you're building a data model, you have that relationship, but later, if you load more data, it's changing to a one-to-many. So think about, if you have in one table, you know it's a fact table, so it's necessary to have foreign keys in the table. You change the one-to-one relationship to a one-to-many. And then we have the many-to-many relationship, and that's a very weak relationship. It's not a strong relationship like the one-to-many. So I don't use the many-to-many relationship. You'll see a many-to-many relationship sometimes if you have an accountant with a bank. An account have multiple account holders, and some account holders have many accounts. So there's a better way to create a strong relationship between the many-to-many, or if you have a many-to-many relationship, we can do that a lot better. Later in this presentation, I explain how you can create a better relationship between the many-to-many tables. So you can also choose the filter direction, and we have two choices for that. We have the single. So the single is we filter from the dimension to the fact, and if we use that relationship, that is the best relationship. But sometimes it's possible of some users use the bidirectional relationship, and in that case it's possible to reach the table on the one side and also on the many side if you use a one-to-many relationship. But the problem with a bidirectional relationship is you create an ambiguous model. And also later in this presentation I give you an example what's happening if you use bidirectional relationship. So be careful with the both of the bidirectional relationship. Don't use that in your data model. Okay, so we now understand how we create a well-designed data model with a star schema or sometimes a snowflake schema, and also how we create the relationships. But sometimes it's necessary, or sometimes in the most cases you have multiple fact tables in your data model. So, and that's no problem. If you want, you can create a whole galaxy. So how work a star schema? Want if you have multiple fact tables, you have different star schemas, and they are linked to each other with dimensions. How work that? Now, let me show you. In this example, we have two fact tables, the sales table and the inventory. And they have both a relationship with the date dimension and the product, and that's also a dimension table. So we see the relationship, it's one-to-many. So we filter from the dimension to the sales. And both fact tables react on the filtering from the dimension. So if we have a certain date, the 1st of January, then we filter the sales table but also the inventory table. And if we choose a product, we filter also the sales table and the inventory. So it's always important to have a dimension what reacts to multiple fact tables. And in the most cases that is a date dimension and a product dimension. In this case we have also a store table and a customer table, both dimensions. And if we filter on the store, we filter only the sales table, so not the inventory table. We have no relationship between the store table and the inventory. So, and that's also possible. Sometimes in your data model, you have dimensions, they filtered certain fact tables, but it is possible that the dimensions not filter all the fact tables in your data model. And that's also not necessary. So, and if you focus only on the sales and the dimensions around that, you'll see the star schema. And if you focus on the inventory and you focus only on the dimensions around the inventory, you see also a star schema with two dimensions, but it's a star schema. Then the ambiguous. I've explained with the relationship if you use bidirectional relationship, it is possible to get an ambiguous data model. So what's happening in an ambiguous data model? So I prepare a Power BI file with this data model. So the model have two fact tables, fact sales and fact inventory, and two dimensions, dim product and date. I create also a report, and no, that's not my best work to create a report, but it's enough to explain what's happening in the data model. So I have a report, and so I select in this report the 1st of January, and we have in the inventory, we see here the values from the table fact inventory. We see we have 100 apples, 100 bananas, and 100 oranges. That's stored in the inventory. So if I select the 2nd of January, we see we have 50 apples and 50 bananas stored in the inventory. So this works perfectly. If you go to the model and we create between the fact sales and the dim product a bidirectional relationship. And we go to the report, everything works well. So the values are correct and there are no wrong values. In this case, you get always the right values. But it is possible Power BI choose the wrong way in the model. But I think in 99% of the cases, the values are always correct. But if you have a model with a lot more fact tables, a lot more dimensions, and you use bidirectional relationship, sometimes the path what must follow between the tables is not very clear. So we help this model a little bit and we delete the relationship between the fact inventory and the date. So we can see what's happening with an ambiguous data model. So if we go to the report, we see two dates. We filtered the 2nd of January and we get the dates for 1st January and the 2nd of January. And we see also the apples. So what's happening? What's the reason we get the wrong values or the filtering don't work on the date column? Let's go to the table view and we start with the table date. We have a filtering on the 1st of January. So we select the 1st of January. So in the model, we have the filtering on the 1st of January. We go to the next table. That's the fact sales. So we use that filtering. So we go to fact sales and we select only the 1st of January. So we see we have sold 2 times 1 apple. We have only apples here. So we go through the fact sales. So we have a filtering on the 1st of January. We go through the fact sales. So we have a filtering on the 1st of January. But we have only apples. So we have also a filtering on the product apples. So we go to the dim product. Normally, if we use the relationship on the right way, we have only filtering from the dimension to the fact, but in this case we have the bidirectional relationship, so we can through the fact sales to the relationship to the dim product. So if we go to the table with dim product, we have no date. So the filtering of the date, the propaganda of the date is don't reach the table product. But we have a filter on apples, so we filter on the product apples. So we go to the next table. but we have only a filter on apples. We go to the fact inventory and we filter only on the product apples. So date is not propagate, so we don't have a filtering on the date. And in this case, we see we have 2 rows. For the 1st and the 2nd January, we have 100 apples on the 1st and 50 on the 2nd. And we have only a filtering on apples. And that is the reason we see in the report these 2 rows. So that is the reason don't use bidirectional relationship in your model. If you have a relationship in a bidirectional relationship, you don't know which path Power BI is follow to reach and calculate the values. So never use a bidirectional relationship. There's one case you can use a bidirectional relationship. I show you that later in this session. So back to the sheets. So sometimes I come with a customer and I see multiple date tables in the data model. And the reason behind that is if they create a relationship or between a date table and a fact table, and they have more columns with dates, and they will also create a relationship between that, the relationship is not active. So they solve the problem with multiple date tables, but that's not the right approach. If you have multiple date tables in your fact table and you create a relationship between that fact table and the dimension date, you have multiple relationships, but one relationship is active. If all the relationships are active, you have also an ambiguous data model. And if you have multiple date tables, you have extra data to your model. And we know now, I've shown you that in the presentation, if you have repeating information, if it is not necessary, don't duplicate data in your model. How we can make the relationship active if you want compare dates between each other? We can use a DAX function, and that's named use relationship. So if we create a relationship, or if we create a measure which needs the not active relationship, you can make the relationship active with use relationship. So how work that? In this example, we have the fact sales and we have the date, and that's a dimension. So we create a filtering between date key and date. So that is the active relationship. So that's the line. Then we have also create the due date. It's not right marked, but due date is under the line. And we create a relationship between due date and also date. And we create the relationship and it's a dotted line. Dotted line means it's not an active relationship. So I've created a table, and in the first column we have the total sales. And we use there a simple DAX query, and everybody who have followed a training have created a total sales. So it's a sum X, it's a fact sales, this sales quantity multiplied with the unit price. So there's a very easy DAX query, and you get the total sales for that. So that's the first measure. So the next measure is the total sales with the due date. So what's happening? We use the same measure, but around that we use a calculate. And a calculate have always a filter option. And the filter option is in this case use relationship. And so we use the function use relationship, and we say use the date column in the date table and the relationship with due date in the fact sales. So that's the not active relationship. So the calculate filtered always first. So in this case, he creates the relationship, he makes the relationship active, and then he calculates the total sales. So in this case, we can calculate the total sales for the due date. And we can compare that with each other. This is how you use not active relationship, so you can make them active. So you don't need a lot of date tables in your data model. You can use one date table and you can create many relationships between different tables. And that keeps your model clean, simple, and optimized on the right way. So the next slide is level of details in the table. And this is one of the questions you must ask before you create your data model. A well-designed data model starts always with understanding reports requirements. So ask your stakeholder in what level of details he wants to see his visualizations. Is that the daily totals of every individual transaction? It's very important. If you want to see only the daily totals, the table with the fact tables is a lot smaller than if you want to see every individual transaction. Then you have more rows, and more rows is more memory. And more memory is a slower performance. How smaller the tables, how faster your data model is. So, the many-to-many relationship. In the slide with the relationship, I told you a many-to-many relationship is a weak relationship. So, how we can create a strong relationship? So in this example, we have books and writers, and one writer can write many books, and one book can have multiple writers. So a direct relationship between writers and books causes an ambiguous and an unreliable result. So how we can fix that? We fix that with a bridge table. In the bridge table, we have the book ID and the writer's ID, and every combination what's possible between that IDs. We can, from the writer's table, we reach the bridge table, we go to the bridge table, and normally if we have a normal relationship, one-to-many, and we have a filter direction, also one-to-many, then is the bridge table the last table what we can reach from the writer's table. So in this case, and this is the only case, we use a bidirectional relationship. If we use a bidirectional relationship, we go through the bridge table, we go to the books. So if we have a writer ID, we see in the bridge table the writer ID and all the books he have written. So we have, in this case, multiple book IDs. We reach the books, so we have the title of the books. In this case, we can also reach the publication date. So we see also the publication dates. But you create a bridge table, and then you have two relationships, one-to-many. And yes, the bidirectional relationship, but you have a strong relationship between the tables. So you can see how the relationship is created. So this is the best solution if you have a many-to-many relationship. So you get a clean performance and a reliable data model. So a little bit a recap, but the importance of the star schema for the Vertipack. A star schema boosts the performance by simplifying the model. So separating the fact and dimension improve the query speed and reduce model complexity. But also proper data preparation improve also the compression and lower the RAM usage. And why that is important and what the effect is of that, I show you in some examples. With small tweaks, we reach big gains. Let me show you how we can optimize the data model with small tweaks. So the first is the keys. So let me show you the information. I have a table, 1 million rows. and it's an, if I click on the column, you see it's a number. If I use external tools, I go to Doc Studio, and it's open on the wrong window, but here it is. I go to the Advanced tab, View Matrix, and the summary. So we see the data model in memory is 6 MB. So let's change the column and change it from a number to text. And you get the view matrix. So we have the model was 6 MB in memory. So if we now go to summary, we see the model is 48 MB. So it was a small change in the data type. Best practice from Microsoft is use always for the keys a numeric value, not a text. And I see with a lot of customers, I see they use text for a key. So that have a big effect on your memory use. So change the key always to numeric value. That's the best option. So you compress it on the best way. So that was example 1. And we see it was not a very big change. So let's go to the next one. And that's decimal numbers. So I go to the table and we see all the values. So we see in the column decimal value, we see digit after the decimal point. So you can ask yourself, is it necessary to have a lot of digits after the decimal point? And sometimes it's meaningful, but in the most cases not. But you must always ask your stakeholder, is it necessary to have a lot of digits after the decimal point? So what's the impact on your data model? We go again to Doc Studio. We go to the Advanced tab, View Matrix. And we have a model, it's not very big, but 2 columns. It's 56 MB. So back to the report. And normally, if you have a decimal point, Power BI stored always the column in a decimal number. So if you have a lot of digits after the decimal point, it's stored in your data model. But if it is not necessary, you can also choose for fixed decimal number. And if you choose fixed decimal number, you have 4 digits after the decimal point. So you have less numbers and you get more unique values in your column. So let's check in Doc Studio what's the impact on your memory size. So it was 56. And we go to the summary tab. It's 9 MB. So it's a lot smaller. And this was 1 million rows. So if you have a fact table with billion rows, the impact is a lot. So ask yourself, is it necessary to have a lot of digits after the decimal point? So the last example. One of the rule of thumbs is don't use calculate columns. Calculate columns have impact on the size of your data model. So in this case, I've created a calculate column. Let me show you the data and the calculate column. I create a switch with a labeling. So it's not a very impactful calculate column, but it's an example. So we have 3.4 million rows. So the we have more rows than the preview examples. So we go to Doc Studio. Doc Studio is one of the tools I use a lot to see the size of the memory, and if I change something in the data model, what's happening, so I can reduce the size of your data model. We go to the Advanced tab, View Matrix, and it's 8 MB. So it's not a big data model, but I have also prepared another example where we go to the data model, and I've created the same docs query. Now I have created in Power Query. So if we go to Power Query, transform data. So in Power Query, I have here, I've created a category column. Did the same step what I've done with the docs query in Power Query. So, but if we do this step in Power Query, if we refresh the model, it's calculate what is needed for the column. And if that is done, the Vertipack engine compress the data. If you haven't calculate column, then it's calculate after the refreshing of your data model. So Vertipack compress the data on the optimized way, and after that step, the column is calculated. And yes, there is a little bit compression on the column, but it uses Vertipack not in the right way. So don't use calculate columns in your data model. I use calculate columns a lot, but only in the developer's environment. If I know the values are correct and everything is right, then I build the calculate columns in Power Query, or the best way is always in the data warehouse. So I build it in the data warehouse, so I receive only data. That's the best approach for the calculate columns. So don't use calculate columns in your model. But what's the effect on the memory? So I close the Power Query. I go to You load the data. Then we go to the extend tools, Doc Studio. The advanced tab, View Matrix, go to Summary, and it's 7.9. So it's not a big impact on your data model size, but also the small adjustments are important. So don't use calculate columns in your data model. Also optimize your data loading for the compression. So load only necessary data to achieve optimal compression. Reduce the number of columns per table. Fewer columns lead to more effective compression. Too many columns is ineffective with sorting and weaker compression. So I aim for a maximum of 15 columns per table. It's a guideline, not a rule. And always ask yourself, is this column really needed in the model? So what are the best practices from the data modeling? Always use a star schema or a snowflake schema if necessary. A fact table contains values for calculations, and dimension table contains values for filtering. Avoid using bidirectional relationship. Include only the data you actually used, and determine the level of details for your tables in advance. Choose the right data type for each column. I wish you all a wonderful Christmas and a very happy and a healthy New Year. Thank you for attending this session, and I hope to see you again somewhere in the new year.